Astronomers have been watching for a long time. One of the brightest and most enigmatic stars in the night sky, Betelgeuse, a colossal red monster on the edge of crumbling. Yes. They stated that it was coming. Their only uncertainty was when. The James Webb Space Telescope has captured something that no one believed we would ever see. As soon as Betelgeuse started to explode, a cosmic shock, a dying star's waver, a glimpse into the undiluted power of the entire universe. This isn't just another observation from deep space. This is a once-in-a-lifetime occasion, the nearest supernova that humans have ever observed. And Webb's observations have evolved everything. The shoulder of Betelgeuse, within the Orion constellation, is unlike any other star. It is more than a red supergiant, 700 times larger than our Sun and roughly 20 times as massive. For decades, scientists have known it was swelling, erupting, and unstable. It suddenly vanished in 2019, triggering worldwide speculation. Was this the final moment? Was it exploding into space? With the precision of the Webb Telescope, the mystery has grown. For the first time, we are observing indicators in real time. Massive energy. Stars collapse, discharging, shifting surface convection, and chaotic twisting of magnetic fields. Betelgeuse is more than just dying. It's transforming right before our eyes. The James Webb Telescope has been focused on Betelgeuse for months, using its infrared vision to peer into layers invisible to any previous observatory. The data are now in, and what it demonstrates is stunning. Convective bubbles, the size of Jupiter, can be seen bursting on the surface. We can follow hot gas plumes exploding into space at incredible speeds. And hidden within the light spectrum, a distinct shock wave is moving through the star's outer layers. For the first time ever, astronomers are observing a star's actual physics tearing itself apart. It is not a simulation. It's the anatomy in real time of a supernova. It takes place only 642 light-years away from Earth. In contrast to other supernova that occur in distant galaxies, Betelgeuse is close, cosmically speaking. Its explosion will eventually become so brilliant that it could be observable throughout the day and brighter than the entire moon. But more importantly, its proximity gives scientists a once-in-a-generational chance to learn about a star's demise up close, how its very core collapses, how elements like carbon and oxygen are forged, how the shockwave reshapes the surrounding space. What Webb captured is more than just a dying star. It's the very thing that results in the components of life, the same components that gave rise to Earth and us. We are observing the reverse of our cosmic ancestry. The explosion of Betelgeuse is more than just a spectacle. It is a key that unlocks the processes beneath galaxy formation, planetary systems, and the life cycle throughout the universe. Webb's advanced tools allow us to model the final stages of stellar evolution with unmatched precision. We can now comprehend what takes place inside a dying star. Also, we may even comprehend the indicators to look for in others, potentially foretelling future supernova long before they happen. This is not limited to science. It's Shakuna moment where humanity looked into the void of time and witnessed the light exploding back. The explosion of Betelgeuse is not a one-time event. It creates a shockwave across vast distances, impacting the surrounding interstellar medium. Webb has already identified the early ripples moving high-energy particles outward, heating surrounding gas clouds and altering the shape of the star's dust halo. However, there is another issue, a shift in gravity. Even at 642 light-years, the apocalyptic shattering of Betelgeuse's core may have sent out gravitational waves, the kind we've only just begun to detect. This, if confirmed, would mark the first time we've linked directly visible supernova data to gravitation. And that would rewrite all of the information we have about the interaction of light with matter and spatenep. As Betelgeuse collapses, one of the most pressing questions in the cosmos returns. What remains? A neutron star? A black hole? Or something else? The Webb-based data suggests that the demise of Betelgeuse may not be completely uniform. There are electric field disruptions, plasma voids, conceivable asymmetries in the fallback space, does not escape material but is dragged back in. Some astrophysicists are even speculating about a transitional object, a phenomenon that sits between a theorized neutron star and a black hole, but never observed. If Webb has detected this action, it would be the initial direct sign of a new kind of cosmic object, with just 642 light-years between the explosion of a star and Earth. Many have asked, are we in danger? The quick response is no. Betelgeuse is not dangerously close to Earth, but the more comprehensive response is complex. The explosion will release a gamma wave of higher energy particles, expanding electromagnetic radiation bursts. These could potentially disrupt clouds of cosmic dust that influence other star systems, even trigger changes in how we get light from other places. For now, Webb is keeping a close eye on the velocity and spread of this radiation front, because despite our safety, the explosion may alter the optical structure of our galaxy's community, changing how we observe the universe from here on out. Betelgeuse is enormous, old, and powerful, but it is failing, a reminder that even stars, those enduring lights in our sky, have limits. What Webb has captured isn't just the death of a star. It's like looking into a cosmic mirror. Everything that lives ends. However, in that end, new components emerge. Rising stars will rise from Betelgeuse's ashes. In the ensuing chaos, new worlds may emerge. This is not destruction. It is cosmic rebirth. And we were blessed to observe it among the vast data collected by the James Webb Telescope. Scientists discovered something unexpected: variations in the composition of the elements in the ejected debris. The fireball of Betelgeuse is releasing not just iron, oxygen, and carbon, but rare elements like yttrium and technetium, formed only in supersonic environments. How significant is this? Because examining these elements' ratios enables researchers to trace the life cycle of matter in our galaxy, from the core of dying stars to the dust that forms planets to the atoms inside you and me. Webb is more than just recording an explosion. It's decoding the chemical script of how life can be lived. And Betelgeuse, in its final moment, is telling a story that started long before Earth was real. Betelgeuse won't come back. Its place in Orion will grow into an expanding cloud of superheated, glowing gas and debris. However, its death is not the end. It's a gift of knowledge, of elements, of perspective. It reminds us that our sun, too, will one day fade, that even the brightest stars in the sky have a final scene. Nevertheless, this conclusion carries the blueprint for all new things. Without supernova, there are no oceans, no planets, and no life. And now, with the James Webb Telescope, we can finally witness that full cycle. From the fiery depletion to the basic materials of creation at 642 light-years. In the icy silence of space, a star's life has come to an end, not with a whisper, but with a magnificent last roar that spread through the dark for centuries until it arrived at us. Thanks to the James Webb Space Telescope, we didn't just see it. We comprehended it, the indications, the collapse, the detonation, not as a legend or a metaphor, but as fact. In its end, it provided us with responses to questions older than humanity itself. Where do the elements come from? How do stars ever exist? And what will happen to our sun? In that dying red light, Webb has seized more than a supernova. It accurately portrayed our genesis as well as a glimpse of the future. So now we ponder, what else is the universe prepared to tell us? And are we actually ready to witness it? Let us know what you think in the comments. Did this rank as the highest, most important stellar event of our time? And what is the next cosmic mystery the James Webb Telescope will reveal? Subscribe and turn on notifications, because this is far from over. It marks the start of what comes after the stars.